Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem vertical sum from GFG. Let's read the problem. Given a binary tree having n nodes, find the vertical sum of the nodes that are in the same vertical line. Return all sums through different vertical lines starting from leftmost vertical line to the rightmost vertical line. Just like in this case, if you see, let's consider this column as 0 column, this column as -1 column, and this column as -2 column. Similarly, consider this column as 1 column and this column as 2 column. In 0th column, these nodes are considered because when you go left and when you go right, you are coming to the same column 0. In this case also, when you go right and then when you go left, then you come back to the 0th column again. So if you do sum all these columns nodes, for -2 column there is only one node, so the corresponding value for -2 column is 4. For -1 column, the node is only 1, so you only write 2. For 0th column, there are 3 nodes, so you have to sum it up. Let's do sum 5 plus 6, 11 plus 1, 12. So you print 12. When you consider the first column, there is only one node, so you write it itself. Similarly, for second column, you write only 7. So you should print this list as your answer, just like in this case. And this is the first you specify a column and then give the sum of all nodes present at that column. I hope present all nodes at that column. I hope you got the question well. As you can see, there is a column and the corresponding sum of all nodes present at that column. So in my approach, I consider a tree map, because in tree map the order of key is sorted, so you are not don't need to worry about the order of column, because in tree map the key order is sorted. When you are at a -2 column, that node is considered first, and then the -1 key is considered second, then 0th key is considered third, and similarly 1 and 2 subsequently. So I hope you got why I used tree map to order key in sorted order. Then in this tree map, the key is the column number and the value is sum of all nodes present at that column. I hope you got this why I considered this tree map and store for why how I use its key and value to store column and sum of all nodes present at that column. Now let's traverse the tree and see how this tree map can be filled. Let's traverse it. First you are at 1, this node, root node, you are at 1 and the corresponding column for this one is 0. If you go to left, the new node is 2 and the corresponding column for this is -1, because you go to left, so you have to decrement your column by 1. Similarly, if you go again left, just like in order traversal, you are decremented your uh, column number and the corresponding column number is -2, but the value present at that is 4. If you carefully see here, the node is not null. The node is presenting something. So you have to consider zeroth column will give you the sum of 1 currently. Similarly, in this case, the node is not null. -1 column is present something. So you have to consider -1 for the key and the value is 2 currently. And in this case also you have to see that there is a column -2 and the node is not null, so you store -2 corresponding 4. Similarly, if you go left and right of this 4, you can see the left and right side are null, so you should return not storing anything to your tree map. Then simply if you do your left subtree traversal for this 2, then you go for right subtree. Because you go right, so you have to increment your column number. Now the column number is 0, and as you can see, the column 0 is already present in my tree map, so I simply add 5 to my that column number's value. The column number's 0 value is 1 current previously, and now 5 can join this, so the new column number 0 value is 6. I hope you got this. Similarly, 10, if you do it right subtree traversal, then you have to increment your column number because you go to right. So in this case also there is no null node, so you have to consider it in your tree map. So there any node 1? No, there is no node 1, so you have to create new one. Similarly, if you do it left and right, then as you can see, if you go to left, then you have to decrement your column number, and if you decrement your column number, now you reach to the 6th, but the column number is 0 because 1 minus 1 is 0. If you carefully see in this case, the is 0 is present in your map. Yes, 0 is present, so no need to create new 0. You have to add this 6 to your that 0th value. I hope you got this. And similarly, if you go to the right subtree, then you can see there is non-null node, and the column number is incremented by 0. So the column number is now 2. Is 2 present in my tree map? No, the 2 is not present, so you have to create new key as number 2 and store 7 to it. If you traverse your tree map top to bottom, because tree map stores the key in sorted order, so if you traverse the tree map top to bottom, then the values are 4, 2 and 1 plus 4, 2 and 1 plus 6, 5, 6 plus 6, 12, and then 3 and then 7, just like in this case. So I hope you got this, how you can use tree map, and how the simple traversal can uh, fill the tree map. I hope you got this. So for every stage there are only two values. First the node and second the column. If node is not null, then simply add that element to your corresponding key, that is column. This is held when the column is not present in the column is present in my tree map. If the column is not present, then I have to create. If the column is not present, then I have to create new column as key and store the value corresponding to it. I hope you got this, and you can see in this test case also, whenever I have no key in my tree map, then I have to create new one and store it corresponding to that key. And if the key is present there already, then I simply add the value to it, simply as that. Simply add that element to your corresponding column. I hope you got the intuition very well. Now let's jump to the code. Here is my Java code. Let's discuss it. First I initialize my tree map, and I do DFS from root and the corresponding using map, and the starting column is 0. This is representing the starting column. If you go to left of it, then you decrement your column. If you go to right of it, then you increment your column. Let's do DFS on this tree. If you do DFS, then if the root is not null, if the root is null, then simply return. If the root is not null, then add that element to the corresponding column if that is present. If it is not present, then create new one. This statement will create a key if it is not present. In this case, the key is column, and if it is present, if it is present, then it simply add that node dot data into that column's value. I hope you got this, how map.get or default plus root.data can do this. And similarly, you go to the left subtree and the right subtree. Carefully see that when you go to the left subtree, you decrement your column by 1, and when you go to the right subtree, you increment your column by 1. I hope you got this code, and my code is clear to you. Thank you for watching my video. Please like and subscribe my channel. Thank you.